All right, so today we're finishing up chapter 2.2. We've been talking about quadratics. Today's learning target, just one learning target. I can use quadratic regression. So an application of quadratics here. So we're going to read this story problem. We're talking about our athlete here, Esteban. Esteban is throwing his discus, and here's the path that the discus is taking. So we can read this as he throws it out 1 meter, the disc travels up to 1.75 meters high. And then at 2 meters out, the disc is at 2.71 meters high, and so on. It follows this path here. So what we're trying to do is we're trying to predict at what height will the discus be after 15 meters. So if you notice on our diagram here, it only goes out to 10 meters. So we want to predict what will happen at 15 meters. So this disc is going to follow a parabola. It's going to reach a maximum height at some point, and then it's going to start to come back down, just like a parabola would, because it is following that path. So what we want to do is we want to figure out, what does this quadratic equation look like? So we're going to use a graphing technology. So if you're using a TI 83 or 84 calculator, it's going to ask you for two lists, a list 1 and a list 2. But the program we're using today is asking for X and Y. So the list 1 would be all your X coordinates, and the list 2 would be all your Y coordinates. So the X's would be all these first numbers in your ordered pairs. So 1, 2, 3, 4, and so on down the line. And then the Y values are the second number in your ordered pair. So 1.75, 2.71, 3.52, and so on. So I've started the list here so you can get an idea of what it looks like, but you would go all the way until you reach the numbers 10 and then 8.55. So let me show you what you'll see when you hit the link. So go ahead and hit the link there. All right, so this is what my screen looks like. So I'm looking for this equation here, this y equals a plus bx plus cx squared. Now notice we've been working with ax squared plus bx plus c. So they're swapping those a's and c's there. It still works the same, just they're calling them different letters. So just keep that in mind when you get your answer. So what you're going to do is you're going to put in for x. If you already have numbers in there, when you click on the link, push clear. So clear them all out first. To save time, I already have these inputted here. So what you would do is you would click on that first value, type it in, and then arrow down to the next, the next, the next, the next, and then you go over to the y's, type it in, arrow down, and enter all the y's, okay? So once you have your list filled in, you're simply just going to click on the execute button. So this is right under your chart where it says execute. Click on that. Okay, and let it think. And then you're going to scroll down. This is your answer down here. Also notice this is cool. It's graphed it for you. This looks like the diagram we have on our note packet. But what you're going to do is you're going to fill in the A, B, and C here. These are the values that we are looking for here. All right, so remember they're going backwards. They have A plus BX plus CX squared. So that C is really the A term that we want. So C is what goes in front of the X squared. So it's going to be negative 0.03, because we're going to round to the nearest hundredth. So you look to the next one, 7 is higher than 5. So this rounds to negative 0.03. x squared, plus 1.06, that's going to round up, x, and then plus 0.67. So that would be your equation. That would be the quadratic equation that this parabola is following, the path here. So what does that look like? It looks like, so we start with our c term, so negative 0.03 x squared, and then plus 1.06 x, and then plus 0.67. All right, so that's our equation. That's the quadratic equation. So if you were to graph this, you would see this basic shape here. Now, we want to figure out, remember, let's go back. What are they asking? They're asking, predict what happens at 15 meters. So 15 meters out, that's your x term. So you're going to plug in 15 in for your x. So plug in 15 everywhere you see an x there. All right? And then simplify it down. So you do 15 squared and then times it by negative 0.03. And you get negative 6.75. Then multiply 1.06 times 15, and you get 15.9, and then plus 0.67. And then add those all together, and you get 9.82 meters. So at 15 meters out, this disc will be 9.82 meters high. All right,